Hello, geometry students. Welcome to lesson 11.2, volumes of prisms and cylinders. Let's get right into it. So we're looking at volumes of prisms first, and cylinders are really the same formula. If you're thinking of volume, it would be thinking about how much it would take water, something else, some other substance to fill this box, to fill this rectangular prism. Likewise, how much water, whatever substance you're talking about, would it take to fill this cylinder up? So if you found the area of the base and then took that and multiplied it by the height, blah, 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 if we're filling it up with water there it fills it up all the way to the top. If you take the area of the base times the total height of that prism. So the formula for volume of a prism cylinder, really the formulas for volumes of all kinds of shapes are actually a good deal easier to deal with than surface area formula. So the volume formula for a prism is just capital B standing for the area of the base and then H for the height of the prism. So this is area of the base and this is the height of the prism. And on the picture, I'll put a capital B there, so that B, area of the base, and then height going from there to there, the height of the prism, connecting the two parallel and congruent bases. And so that's what that B is referring to, that's what that H is referring to. And then likewise for the volume of cylinder, really B is just a circle every single time. And so I'm going to put an R in here, put an H there. So it's really the same formula, B times H, but more specifically, we can always replace B in a cylinder with pi r squared because it's always going to be a circle. So the area of the base of any cylinder, always a circle, always pi r squared times H. So this is the formula that we'll use for that. So we're going to start off here directly with some cylinder stuff first because I think it's a little more straightforward. The base is always a circle, and then some prism stuff to wrap it up because sometimes those prism bases are different from one shape to another. So here we have the volume would be, we're just finding volume for example 1. Here we're not doing any surface area, but you should still remember that stuff, I hope, from previous lessons in the previous chapter. So we're going to be starting with pi r squared H for this one, and on this one I've given you all the information you need directly, so nothing to solve for here. R is 4, the radius is 4. We're squaring that and we're multiplying that by 12. If you had to leave this in a pi form, we would say 4 squared is 16. 16 times 12 is 192. So you've got 192 pi, or approximately 603.2. And units are included, centimeters. Now we're multiplying. This is like 4 centimeters times 4 centimeters times 12 centimeters. So centimeters times centimeters times centimeters. For volume, it's always going to work out this way, centimeters cubed. So be careful that you're doing units appropriately there. Centimeters cubed, not centimeters squared. It's not area anymore, it's volume. So exact answer would be like that, centimeters cubed. And then to the nearest tenth, 603.2 centimeters cubed. On this one, a little extra work to do here. I'm going to call this H right here, from here to here, and you can see then we have a right triangle right here. 25, 7 is a diameter going all the way across, and H is the height. A bit of a contrived problem. I'm not sure who would give you a measurement from that corner of a cylinder to that corner, but we're just making you think and consider how would I figure out H from there. So it looks like a Pythagorean theorem problem. H squared, the leg squared, plus 7 squared equals 25 squared. And then we'd have H squared plus 49 is 625. If you subtract 49 from both sides, you'd be left with H squared equals 576. And then take the square root of both sides, leaving you with H equals exactly 24. That's a Pythagorean triple, 7, 24, and 25. And then from there you could take it and plug it into your formula. You've got pi r squared H. For this, D is 7, diameter 7, so then we're going to divide that by 2, and we'd get the radius as 3.5. So we're going to take 3.5, plug it in there. We're going to take h, plug it in there, and see what we got from there. So you've got pi times 3.5 squared times 24. And then doing the work on a calculator for that, 3.5 squared times 24 ends up being exactly 294. And you have that times pi, so that would be in feet cubed in a pi form or exact form. If you round that off, plug that into a calculator, take the time to do that, have your calculator out as we're going through this lesson here, type it in, make sure you're getting the same thing using your calculator. Use the pi button on your calculator, not just 3.14. It gives you a better answer with the pi button on your calculator. You have 923.6 feet cubed for that one. And then one more slide, keeping this lesson relatively short here. The volume of all these prisms. So we've got 4 different examples. Looks like a rectangular prism here, 2 triangular prisms down here, and 1 trapezoidal prism. I think that's a new one for us in the notes at least here. So we're doing volume is capital B times H on every single one of these. So I'm just going to start by putting that on every single one of these, including that formula every place. And so from there, let's figure out what our base is. So my bases are, I could pick left and right, I could pick front and back, but I chose to pick top and bottom. On this one, rectangular prisms. Here it's got to be the triangles. And then here it's also got to be the triangles. And then on this one, it's got to be the trapezoids you see there. So those are the bases in each of those pictures. And so for the base, the area of the base of a trapezoid, we would be thinking that's length times width or base times height. So I would have for this capital B 5 times 4. And then the height of the prism, part connecting the 2 bases, would be 10. If I do 5 times 4, that's 20. 20 times 10 is 200. So I have 200 centimeters cubed on that one. Over here, I have to remember my trapezoid formula for this one. So that was 1/2 B1 plus B2. In other words, the average of the bases, or the length of the mid-segment that would be connecting it from here to here, times the height of the trapezoid. So this is capital B. This is all just in respect or with respect to the trapezoid, and then times H. So this is times the height of the prism. This H not the same as this H. So this H are 2 different H's, or they stand for 2 different things. So let's figure out what we've got here. 1/2, and then B1, if it's 5 down here, so it'd be 5 up here. It's a safe assumption with this problem. And then 2 up there for the second base. And then the height of the trapezoid looks like is 3 right there. So we've got that times 3. And again, this H not the same necessarily as that H. The height of the prism connecting the 2 bases is 6. So from here to here, connecting those 2 bases, looks like we've got 6. That 3.5 here is unneeded information for this particular problem. So from there, we've got 5 plus 2 is 7. 7 times 3 would be 21. 21 times 1/2 would be 10.5. So it looks like I've got 10.5 times 6. 10.5 times 6. 10 times 6 would be 60. 5 times 6 would be 3. Put that together and you have 63 centimeters cubed for that one. On example 2, part C, rather, it looks like we've got the area of the base. In this case would be 1/2 base times height, this height being the height of the triangle, and then this H being the height of the prism. So again, this one and this one, this H and this H might not be the same. Let's check it out, plug in what we've got. So it looks like the base of the triangle is 16, and the height of the triangle, or 12 rather, sorry, and then the height of the triangle is 16. So I've got 1/2 times 12 times 16, and then the height of the trapezoid, this 20 is referring to this length from here to here. So we've got that times 20. And so this one would be 1/2 of 12, which is 6. 6 times 16 is 96. And if I multiply that by 20, I have 1,920 meters cubed. And then finally for this lesson, looks like we've got another triangular prism, so I'm going to be thinking 1/2 base times height once again, and then times the height of the prism. Height of the triangle here, height of the prism here. If you wanted to do something like this, you could, a little subscript, so like I'm going to say subscript lowercase t for triangle and then lowercase p for prism. Maybe you want to do that on all of these. It's totally up to you. For my sake, I wouldn't be taking off credit for something like this. This would be for trapezoid and prism here. But as long as you understand that this h and this h are not necessarily the same values, then I think you're good to go with this. So we've got 1/2, and then area of the base, 1/2 base times the height of the triangle. So we've got all the information here for that. I don't need to figure out this side. It would end up being 25 based on the work we did. Over here, a 7, 24, 25 triangle is always going to work out. So that would be a Pythagorean triple here. But I don't need that information. I'm not figuring out the perimeter of the base here. I just need the perpendicular parts, the base and the height. So I've got 1/2 times 24 times 7. And then times the height of the prism would be 28. So it looks like I've got half of 24 is 12. 12 times 7 is 84. And then that times 28, you can use a calculator for that to get you 2,352. No units included in this one, so if you left them out, I'd be okay with that. But if you're going to write in units, write the word units and then put cubed after that. So I think that's it for this lesson, a relatively short one. We'll take a look 11.3 next, volumes of pyramids and cones.